Hi everyone, in this video we are going to practice doing a couple different stoichiometry problems. Please note that this video is meant to be the second video of a three-part series, and so if you haven't watched the basic stoichiometry video first, please go back and do that. Otherwise we're just going to go ahead and start doing the more complicated stoichiometry problems. After this though, we're going to have a video on limiting reagent, okay? So let's do these three problems together quickly, and let's just see if we can get the right answers. So given this chemical equation, how many moles of methane can be produced from 13 grams of hydrogen? All right, did you get an answer? Hopefully you did. The only number that we could start with is 13 grams of hydrogen, so we have to start there. So 13 grams of hydrogen. Now we're going to go directly from grams of hydrogen to moles of hydrogen. So we know there's approximately 2 grams of H2 for every 1 mole of H2. Now we're trying to go from hydrogen to methanol right here. So we know that there are 2 moles of hydrogen to every 1, okay, so that's sneaky right there, there's a 1 mole of methanol. And that's it. That's all we're trying to do because we're just trying to solve for moles of methanol. So we're done. We can see that our grams of hydrogen cancel out, grams of hydrogen cancel out, moles of hydrogen cancel out, moles of hydrogen cancel out, and we're left with mole of methanol. So if you do this properly, you would get an answer of something like 3.25 moles of methanol. Oops, add an H there. All right, let's try another one, okay? How many grams of oxygen are produced from 100 grams of peroxide? So that's H2O2. Go. All right, did you get an answer? Hopefully you did. We only have one number, so you have to start with it, right? So we have 100 grams here of peroxide, H2O2. Now, we're in grams. We're trying to go to grams of a whole different thing. So the only way we can go from peroxide to oxygen is through a mole-to-mole ratio. So we need to take our grams of peroxide and convert that to moles. So our molar mass of peroxide is something close to about 34 grams. It's about 34. So 34 grams of peroxide for every 1 mole of peroxide. Notice that I'm being very, very meticulous here. I'm writing out grams of peroxide, moles of peroxide. This is a spot where a lot of students make mistakes because they start to get sloppy here. And so when you do more challenging stoichiometry problems, I encourage you to write out as much of a unit as possible. Even if it gets in the way, it just usually helps with your bookkeeping at the end. All right, so we're in 1 mole of peroxide. We're trying to go from peroxide to oxygen. So we need to do a mole-to-mole ratio here. So we're at moles of peroxide at the top, so we need moles of peroxide at the bottom. And like I said before, we're trying to get to oxygen, so we need to put moles of oxygen on the top. So now we have 2 moles of peroxide for every 1 mole of oxygen. Okay, so 2 to 1 ratio. Then we're trying to get to grams of oxygen, so we need to take this one step further. For every 1 mole of oxygen, we have 32 grams about. That's not perfect, but remember it's O2. It's a diatomic. It's not a single O, it's O2, so you have to use 32 grams per mole. And if you put this in your calculator properly, you end up with something like 47.044 grams of oxygen, okay? So if you go through here, you should be able to see all of your units cancel out. Gram of peroxide, mole of peroxide, mole of peroxide, mole of oxygen, and you're left with grams of oxygen, okay? Let's try one more. This is definitely the most challenging one that we're going to put on this video, okay? What mass of products is formed from the combustion of 50 grams of methane, okay? 50 grams of methane, we're combusting it. What mass of products? Go, think through it. Did you get an answer? Hopefully you did, but like I said before we went into this is definitely one of the more challenging questions, so please don't get frustrated if you're not there quite yet, but we're going to get through this together, okay? First thing you do is come up with your combustion chemical equation. So we have methane, CH4, we're treating it with oxygen, and then we create carbon dioxide and water. So 2 different products, all right? So when we are determining our mass of our products here later at the very end, we're looking for our mass of both carbon dioxide and water. Now, we have to balance this equation. I can see right now that it's not balanced. We definitely need to make sure our hydrogens are balanced here. Now I have 4 there, so I can add 2 here. Let me make sure that's right real quick. Yeah, okay, good. All right, so now what we're going to do is go through our basic stoichiometry conversion. We're starting with 50 grams of methane here, and we're trying to figure out what mass of carbon dioxide and what mass of water we're going to create. So we need to do 2 different things here. So let's start with our carbon dioxide first, and then we can go to our water. So we have 50 grams of methane, okay? Molar mass of methane is about 16 grams. That's not perfect, but it's pretty close. So we have 16 grams of methane for every 1 mole of methane. We need to do a mole-to-mole ratio in order to get us from methane to carbon dioxide. Luckily for us, we see that there is 1 mole of methane to 1 mole of carbon dioxide. So this math is super easy for us. But we need to take it one step further because we're actually looking for mass here. So for every 1 mole of carbon dioxide, we have about 44 grams, okay? And we can get this off the periodic table. So now if you solve this out properly, all of your units cancel out correctly, and you're left with about 137.5 grams of carbon dioxide. That's beautiful, but we need to also figure out what the mass of water is, okay? So we get same thing here, 50 grams of methane. This first part's going to look the exact same. We still are going to use our molar mass of methane, so that's 16 grams for every 1 mole. This part's where it's going to change. Now, the 1 in front of methane is never going to change, so this bottom part is going to be the same. So we still have 1 mole of methane here. Now is the difference, because now instead of carbon dioxide, we're now trying to figure out what mass of water we're going to create here. So for every 1 mole of methane, we see that we have 2 moles of water. Last piece here, we need to take our 1 mole of water and use our molar mass, which is about 18 grams for every 1 mole, about, not perfect. And if you do this properly with a calculator, you get an answer of 112.5 grams of water. Now, the question asks for what mass of products. So the last thing that you have to do is you add the 2 numbers together. So you do 137.5 grams plus 112.5 grams. So if you were to do this properly, you would end up with 250 grams of products. So that's your carbon dioxide and your water, okay? So hopefully that makes sense. This definitely was a more complicated problem because you had to do 2 different steps, but make sure you're reading very carefully what the question is asking you for. If it asks for mass of products, then you have to determine the mass of all of your products. Now, this question could be really, really difficult if we then also gave you a mass of your oxygen, but that would be a limiting reagent problem, and you'd have to do so much more. So now, this is the end of our second video, the stoichiometry video. Please continue on and watch the third video, which is the limiting reagent video, because that is the most complicated part of stoichiometry. If you can get through all 3 of those problems in the limiting reagent video, then you are golden. You've got this perfect and you perfectly understand it. So hopefully you get there, all right? See you in the next video. Drink water.